Hi everyone, in today's lesson we're going to talk about graphs of exponential functions. An exponential function with base b is defined this way in this equation. So we have y equals a times b to the x power, where b is greater than 0, not equal to 1, and x is any real number. So when b is greater than 1, we'll have something that's called exponential growth. So in this example here, we have y equals 3 to the x power. It's the same thing as saying y equals 1 times 3 to the x. That just means that there's no coefficient in front. So that's fine. And then when I have b that's between 0 and 1, the graph will decrease or decay. So that's where this is a 1/2. So what I'd like to do is graph these two things so you could see what happens to them. So I'd like you to pause the video and grab your calculator and hit resume when you're ready. Okay, so what I want everyone to do right now is type this into the calculator, just the way you see it, into the y equals. So we're going to put in y equals 3 to the x. All right, so type that in. And then we want a table of values, x and y. Now, we're going to do a quick sketch of it. We have values from -4, -3, -2, -1, 1, 2, 3, and 4. So let's just do a few of them. So let's graph, let's see here, -4, -3, -2, -1, 0, 1, and 2. Let's start there, okay? So go to the table and copy down these values for y, and then hit resume when you're ready. All right, these are the values that you should have gotten. So approximately, -4 is 0.01235, 0.030704, okay, so let's graph the positive values first. These right here, they're a little bit easier to graph. So we're going to graph 0, 1, which is easy. That's right here. 1, 3, and 2, 9, which we can't really fit on the graph, but we'll leave it there. And now the values on the negative side. So -1.3 repeated. And it looks like it's getting smaller and smaller and smaller. But actually what's going to happen is that this graph here will never ever touch the x-axis. It's going to approach it, but it's never ever going to touch it. So that actually is called an asymptote, which we'll talk a little bit more about later on, but let's just draw a sketch of this thing. So we're going to start here, and we're going to go through these points, here, here, and here, okay? Now you want to make sure that this graph here never touches the x-axis. So if you graph that on a test, we'll have to take points off if you actually touch it, okay? So now let's graph an exponential decay problem. So again, now type this into the y equals of the calculator and write down y equals 1/2 to the x and go to the table and let's write down the x and y values. And we'll go from about, I don't know, -3 to 3. So -3, -2, -1, 0, 1, 2, and 3. So hit resume when you're ready for the answers. Okay, you should get 8, 4, 2, 1, 0.5, 0.125, down here actually, and this should be 0.25. Okay, so let's graph the positive values in the y first. Let's graph these first. So -3, 8. I know we probably can't fit that, so we'll just estimate. So -3, 8 is probably somewhere here. -2, 4. -1, 2. 0, 1. 1 and 0.5. 2 and 0.25. 3 and 0.125. So if we connect these, this probably should go up a little bit more. Maybe we'll move that point. It's just a sketch up here. Okay, so these are your two graphs. This is exponential growth, it's growing. This one's exponential decay, and it's decreasing. So what do you notice about the similarities between these two graphs? You should be noticing something unique, that they both go through this point right here, 0, 1. And that's always going to be the case. Every exponential growth or exponential decay problem is always going to go through this point 0, 1. And here's the reason why. Because no matter what, if we have an equation, say we have y equals 4 to the x, or y equals 10 to the x, or y equals 1/3 to the x, or negative 1/2 to the x. No matter what the base value is, whenever I raise a number to the 0 power, so 4 to the 0, 10 to the 0, 1/3 to the 0, negative 1/2 to the 0, anything to the 0 power will give us 1. So that concludes that y value will always be 1. So y equals 1 for each one of these, no matter what. No matter what the base will be, I'm always going to have an x value of 0 with a y value of 1. So 0, 1 will be on any exponential growth or decay graph. Okay, it's very important. And also, the graphs always are going to exist above the x-axis, just like here. They never go down in these two quadrants. So let's see if we talked about all of the general characteristics. The graph crosses the y-axis at 0, 1. The domain and range we didn't speak about. So domain is the set of all real numbers. How wide is this thing going? It's going wide to the left, wide to the right, wide and wide, so both of them. The range we spoke about is all positive real numbers, never 0, so from here up, right? Never down here, not in these two quadrants. And the graph is asymptotic, or has an asymptote, to the x-axis. It gets very, very close to it, but it never touches it. So the equation of the asymptote is actually, if I do a dotted line here so you could see it, this is the equation of the asymptote here and here. And I'm drawing it in dotted so you could see it. This is the line that it approaches but never touches. And this is the line y equals 0. Okay? So that line is the asymptote to both equations. Okay? All right, let's move on to the next page. Okay, so now I'd like to speak about transformation rules. Now, we've reviewed these a few times before, but I'd like to review them again. If we are going to be moving up, we always are going to write it as f of x plus c. C goes on the outside. If we're going to go down, it's f of x minus c on the outside. Left is f of x plus c on the inside, where right is f of x minus c. A reflection over the x-axis is a negative on the outside, and a reflection over the y-axis is a negative on the inside. Okay, what I'd like to do now is draw a sketch of this example right here, where I have some transformations going on. Here, I'm moving this down 1, because the 1 is on the outside, and this plus 3 here means to go left 3. So if my original graph was y equals 4 to the x before I did any of the shifting, we know that that is an exponential growth model that's going to look something like this. It's going to go increase. It's going to exponentially grow. So let's just draw a quick sketch, okay? And I know that this graph, y equals 4 to the x, would look something like this. It would start, or it would go through the point 0, 1, and it would look something like this. Again, it's just a sketch. It doesn't have to be perfect. But I'm moving this, and the only point that I really have is this one right here. And I'm moving it down 1, left 3. So I'm going to move that. here. And that's going to be my new point. So I'm going to increase up. Now again, it's a sketch, so over here doesn't have to be perfect. But what's really important is that you understand where the asymptote is. So from the point 0, 1, it's just one below. So here it's just going to be one below as well. Everything gets shifted down one. Okay, so be careful. I mean, it looks, just because I'm on this iPad, it's difficult for me to draw it, but make sure yours does not hit this line, y equals -1. So in this blue equation, or the line y equals, the graph y equals 4 to the x, this has an asymptote at the line y equals 0, where the new shifted one has an asymptote at the line y equals -1. So we want to know, first off, part A, does the graph above represent exponential growth or decay? And the answer is obviously growth, and it's because the 4 is greater than 1. In the formula y equals a times b to the x, the b value is greater than 1. That's what makes it growth. Okay, now the second question says, what are the coordinates of the point that the graph crosses the y-axis? So around here, I sketched it here, but how could we tell if there's no exact point? Well, we know that it's going to cross the y-axis here when the y value, we don't know, but the x value is going to be 0. So we have y equals, let's write this down, y equals 4 to the x plus 3 minus 1. And we're looking for when x is equal to 0. So y equals 4 to the 0 plus 3 minus 1. So that becomes y equals 4 to the third minus 1, which is actually 63. So this thing is going to cross the y-axis at 0, 63. It's a good thing we drew a sketch because it looks nothing like it. And the last question is, what is the equation of the asymptote? Well, the new asymptote is this line right here, the line y equals -1. All right, so jot down any questions that you might have, and please ask tomorrow. Okay, have a good night.